Hi everyone, this week we will be talking about similar triangles. Let's start by talking about similar shapes and what does similarity mean. Let's look at an example of a blueprint. Whenever you look at a blueprint of a building or any design, you will see a term called scale that is given. For example, if a building is 100 meters tall, the diagram cannot be 100 meters. So we say something like 10 centimeters is equivalent to 100 meters, meaning on paper, a length of 10 centimeter would equal in reality a length of 100 meters. This is the basic idea behind similar triangles or similar shapes, creating objects that preserve certain aspects. Example here, I've drawn three shapes, pink, black, and purple. The pink, black, and purple shapes are different. Definitely, they're different sizes, but you can say they are similar because if you zoom in or zoom out, or if you expand the pink, you can get to the black shape. And then if you expand the black shape, you can get to the purple shape. Similarly, if you shrink or contract the purple shape, you get the black followed by the pink. This is the idea of a similarity. Similarly, these triangles here drawn, starting from green to purple to black to pink to blue, are similar. So now we are all set to give a formal definition. Two triangles are similar if the corresponding angles are equal, corresponding sides are proportional. Now what does this mean? Let's look at an example. Say triangle ABC, angles are 80 degrees, 40 degrees, and 60 degrees, and a triangle DEF, much bigger, but the same angles, 80, 60, and 40, and the sides are 5, 7, 10 centimeters, and 10, 14, 20 centimeters each. And the ratio AC over DF is 5 over 10, which is 1 half. AB over DE, which is 7 over 14, is 1 half. BC over DF is 10 over 20, which is also 1 half. And these are all equal. Some common scenarios where similar triangles occur: shadow length and height. Now, at any fixed point in the time, the sunlight makes the same angle with any object. So, if you know the height of one object, let's say you know the height of this object is 10 meters, you can find the length of the shadow of that object. And then let's say there's another object whose height you want to find, you can measure the shadow on the ground, and these triangles are going to be similar because they have the same angle. And so 10 divided by 8 should equal the unknown quantity x divided by 18. You can cross multiply to solve and get 22.5 meters. Another example would be scales on a map. If a scale on a map is given to be 12 centimeters is equal to 100 miles, what is the actual distance between points A and B if the distance on the map is 7 centimeters? So you can think of it as A to B is x, B to C is 100 miles, and 100 miles equals 12 centimeters. Now what does 7 centimeter equal? And these triangles are similar, so you have 7 over x equals 12 over 100, cross multiply, and you get x is 58.33 miles. Another example is if you have two triangles, one inside the other. In this triangle, ABC, the big triangle, and the small triangle DFC, angle C is common, so it's equal. Angle F and angle B equals 90 degrees. And so the third angle also is equal because the sum of the angle is 180. So the triangles are similar. A 1 meter is 100 centimeters. Now when you do these ratios, you have to make sure they're in the same unit. Now choosing the corresponding sides, we have df over ab equals cf over bc, or 100 over x equals 80 over 280. Solving that gives me x is 350 centimeters. Okay, that's the end of this video.